Hi all, welcome to Geeks for Geeks. I am Utkarsh Kesarwani, your DSA mentor, and I am going to solve today's problem of the day. The problem name is the smallest divisor. Given an integer array ARR and an integer k, where k is greater than or equal to ARR dot length. Find the smallest positive integer divisor such that the sum of the ceiling values of each element in ARR divided by this divisor is less than or equal to k. Wait for a second. Yeah. So the question is saying that let me copy this question and open it in my Microsoft OneNote. So the question is saying that you have been given an array and a value k. You have to choose a number, choose a divisor, and you will divide each of the element with this divisor and take the ceiling values, and if you will sum the ceiling values, it should be less than or equal to this key, and you have to choose this divisor as the minimum divisor. So if I will talk about this first example, so 1 2 5 9 it is, and your k is equal to 6 here. So since we need to divide these number, so what is the minimum divisor we can take? We can take 1, correct? And what is the maximum divisor we can take? We always need the ceiling value. If I will take the maximum divisor to get the lowest answer after summing, if I will take the maximum number and divide each of them with the maximum number, so the divisor, quotient will be less. So 9 is the maximum number. So if I will divide by 9 now and take the ceiling value 1 1 1 1. So 4 is the minimum value which you can get in this quotient after dividing. Because if you will take any value greater than this 9, so it will be still 4. Okay. So we are sure that the minimum divisor we can take is 1, the maximum we can take is 9. But we have to satisfy the condition that after dividing with the divisor, the sum of the ceiling values should be less than or equal to k, correct? So the divisor can lie from 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? So these are the values of the divisors. Okay, we need to choose the minimum value. So why not to start with this one? If the condition will not satisfy, we will check for 2 like this. So going for this one, so the quotient will be 1 here, 2 here, 5 here, and 9 here. 9 plus 1 10, plus 7 is 17. But my 17 value is not less than or equal to 6. So it means 1 cannot be our answer. Now I am going to check for 2. So I have to take the ceiling value. So it is 1. It is also 1. It is 3. Because 5 by 2, if I will take in the int, so it will be 2. And since this 5 is not exactly divisible, so we have to also do plus 1 here. It's 3 and it's 5. So the sum will be 5 plus 3, 8, 1, 9, 1, 10. So the sum is 10. Is it less than or equal to 6? No, not. Now check for 3. So I'm going to check for this 3 now. This 3. So here we have 1, here we have 1, here we have 2, and here we have 3. So 3 plus 2, 5, 1, 6, 1, 7. Still 7 is not less than or equal to 6. Leave this thing. Now again you have to go for 4. So here it will be 1, 1, 2, and 3. 3 to 5, 3 plus 2, 5, plus 1, 6, plus 1, 7. So 7 is less than or equal to 6? No, not. Now go for the next value, and which is 5. So if I will divide by 5 now, so it is 1, 1, 1 and 2. So 2 plus 1, 3 plus 1, 4 plus 1, 5. 5 is less than or equal to 6. This hold the condition, so 5 is our answer. Okay. So I hope it clears to you. So what we will do, we will run a for loop. If I will talk about the brute force approach, run a for loop, take my divisor value from 1. Divisor should be less than or equal to 9 in this case, or the maximum value. Just write like this: maximum of ARR, whatever will be there, you can change it according to your code in C++, Java or anything, and divisor plus plus. What you need to do in this, after doing this, you have to divide the values. So you will again run a for loop for going to each index. So for int I is equal to 0, I should be less than n, I plus plus. Okay. What you will do here, you will create a sum variable, sum is equal to 0. You will write like this: sum plus is equal to uh, my current value ARR of I divided by divisor. And also you will check that if your ARR of I modulo divisor is not equal to 0, it means you also have to plus 1. So sum plus plus. Okay. And if your sum value is less than or equal to k, then we will got our answer, we will return divisor. Okay. And that's all. It is also given in the question that your k value is always greater than or equal to ARR dot length. Okay. So the what is the minimum value possible to get after summing? The minimum value was everywhere we have a 1, 1, 1, 1, and after summing these values it should be less than or equal to k. So this 1, 1 can be also find out by ARR dot size. That's why it is given here that your k is greater than ARR dot length, means you will definitely get the answer inside this. Okay. But if I will talk about the time complexity of this approach na, so you can see that here a loop is running O of n time, and here it is running maximum of ARR of times. So it is maximum of ARR, wait, O of maximum of ARR into n. So this is the time complexity for this approach. Okay. Now we are going to the most optimized approach, which is binary search. So you are sure that your divisor will lie between this 1 to this 9, or the maximum value. Okay. So the values are sorted because 1, 2, 3 like this, it is 9. So I will take my starting value as this 1, ending value as this 9. I will find out the mid and calculate. After getting the mid value, that divisor value, we will calculate that what is the sum of the ceiling values. Okay. And if my sum of ceiling value of that mid is less than or equal to k, then what does it mean? It means that you got the answer, but you still can check that whether some still minimum number is possible or not. So in that case you will write that end is equal to mid minus 1. Correct. And in else case you will increase your starting because you have not got the answer, so you have to do mid plus 1, because whatever divisor you have taken, after summing that value or that ceiling value, it is going greater than k. So it means you have to reduce the values. So you need to increase the divisor now, then the quotient value will be reduced. Correct. Okay, good. So and in the last you will return start your as a, your answer. So return start. So let's start the code. So I will take a starting value which will be equal to 1. I will take a ending value. In the starting I'm taking 0 and finding out the size of the array. So arr dot size is the size of the array. Now I will traverse in this array. So for int I is equal to 0, I should be less than n I plus plus. What I will do, my ending is equal to maximum of this ending comma arr of I. Now I will write the code for binary search. So my starting is less than or equal to my ending. I will find out the mid value, and that is starting plus ending minus starting by 2. Okay, I will find out the sum of the ceiling values. So int sum is equal to, let call a calculate function. So calculate and I will pass my array here and my mid here. Okay, then I will check that if my sum is less than or equal to k na, then I will do end is equal to mid minus 1, else in other case it is starting is equal to mid plus 1, and in the last I will just return my starting. Okay, and here we will create that function. So in calculate vector of int and arr and int the divisor, and here I will write my sum as 0, int n is equal to arr dot size, and I will iterate in the loop. So for int I is equal to 0, I should be less than an I plus plus. I will write my sum plus is equal to arr of I by this divisor, and if my divisor modulo sorry arr of I modulo divisor is not equal to 0, so I will write my sum plus plus. The last I will return a sum. Okay, let's submit this solution. Okay, great. So if I will talk about the time complexity of this approach, so you can see that here we are using a binary search. So it should be in log n, but where the values are ranging from 1 to maximum value. So time complexity will be time complexity is O of log of maximum of arr into each time we are also running this function which is running O of n time. So n. So this is the time complexity, and we have not used any extra spaces here. So the space complexity is O of 1. Okay. So have a good day. Bye. And if you have any doubt, you can comment it below.